Hello everyone, this is video lecture for chapter 8, Global Climates and Climate Change. I suppose this will be the most controversial chapter. I'm trying to add a bunch of extra information to this PowerPoint, but that probably won't make it much less controversial these days. So when we're looking at climates, we have a classification system. This classification system is very, very much tied to precipitation, basically, as you'll see when we show some more examples. Excuse me. So the Thornton-Waite system uses potential evapotranspiration. It also uses actual evapotranspiration, right? And so before, when we looked at potential evapotranspiration, Arizona and Florida looked a lot alike, although we know on the ground they're quite different. So there's a bunch of definitions. Take a look at Arizona compared to Florida in this example. And again, this is, basically looking at how much moisture there is in the soil. And that has a lot to do with precipitation and other factors. And you can compare the map with potential evapotranspiration again. I'm not going to, read off every single definition. A lot of these are pretty self-explanatory. Tropical climates. One thing to know, highland climates, they very often just have an H, and sometimes on maps they'll just be a big brown section. Well, the reason is because highland climates have so many microclimates that it just changes, every few feet you may have a slightly different pattern. You may have a glacier here, you may have plenty of vegetation there. There's just so many ups and downs in those areas. So two areas at the top there, I believe the one on the right is in Spain, the other one is, looks like Arizona. Why are they different, even though they look like they're both dry? Well, basically, mesothermal microclimate C means no defoliation because of year-round liquid water present in the soil and no moisture deficit. Whereas in Arizona, there definitely is a moisture deficit, long period of time. Well, most of this is pretty self-explanatory. We've talked about climagraphs before. They're useful for doing an analysis and finding out about one specific area. So this here is Nashville, Tennessee. As you look, well, they get warm in the summers and they get cool in the winters. Not too cool though compared to Minnesota here. And they got a decent amount of precipitation year-round. Excuse me. Again, highland climates, this is an example of microclimates, right? You can have one side of a hill, right, has a forest, the other side, practically a desert. That type of thing happens all the time in highland climates. I'm not going to read every single climate classification, but as you look through those, understand how climagraphs work. So I have 3 examples of different places on the Earth. I also have their coordinates of where on the Earth they are if you want to look them up on a map or a globe, or just Google them. But in a nutshell, you should be able to look at these climagraphs and figure out, well, which is which. If you look at temperature, well, hold on. Sorry about that. So if you look at the one to the far right, that's the warmest. Well, Sudan is in Africa. I think that's going to be warmer than Antarctica or Canada. If you know anything about Vancouver, you'll know there's a lot of rain. You'll see number B there in the middle has a lot of rain. And then you'll see the first one there has the least amount of precipitation and temperature. So it's plenty Antarctica, right? Oh, excuse me, another technical difficulty. Sorry about that, everyone. Always have to have technical difficulties. So some more examples. In my in-person classes, I actually put all this information up and have people work together to figure out which of these coordinates and which of these places equal which climograph. But, you know, for you, I'll just give you the answer and you could study it. So, what's the difference between weather and climate? Well, climate is a long-term phenomenon, right? Weather is short-term, day-to-day, minute by minute, whereas climate is year by year, many years by many years. So, looking at our book, you can see the Earth went through quite a few ice ages. In fact, it looks like the Earth is, through history, has mostly been in ice ages, and there's only relatively shorter, warmer periods of time, one of which we're in right now. So the Pleistocene epoch there was the most recent of the continental ice ages. This is a photo I took when I went to Alaska. Highly recommended if you ever want to go see some glaciers. They get those stripes in them from as they slowly grinding past the mountainside, and they'll come together. We'll talk a lot more about glaciers later, but they're kind of like very slow moving streams in a way, because they are moving but very slow. So that's the question here. Why might some glaciers be growing while others are shrinking during global warming? Well, that's the interesting thing, is although it looks like most of the glaciers of the world are shrinking right now, some are growing, and that's because there are areas where the air moving over that mountainside, for example, is warmer than it used to be, and thus has more moisture in it, and thus it has more moisture to contribute to that glacier. So there are some glaciers that are growing more than they ever have been before. This is more of Alaska. A little bit more glacier. And here's some melting. It's a lot of water coming out these things. There's lots of places where entire populations get their water from the melting glaciers. Excuse me. So, how do we know what past climates look like? I mean, you know, we weren't there, right? So, what do we really know? Well, there's a number of different ways. Different scientists, depending on their interests, try to figure it out, right? It's a mystery. It's, you know, like if you're watching a CSI show, when the criminal detective shows, there a number of different ways. And an interesting thing is a lot of these different methods seem to back each other up. There are controversies and arguments that happen, of course, sometimes very fierce ones among the scientists themselves. But there's general agreement that our book talks about. So one way of looking is radiometric dating, looking at the radioactive decay. Another is looking at ocean floor sediments. Right? They contain seashells that have been being deposited on the sea floor for a long period of time. So you can go down and get some samples and try to look at, you know, what was floating around in the air and in the ocean at the time, do an analysis like that. So a number of these systems bring back a historical graph like this, right? Showing a lot of, well, quick change. And it looks like today is kind of a less eventful time period compared to our larger history. I'm coming up on 10 minutes, so I'm going to start a second